As per the requirement and suggestion, I am explaining the sharing of charges or sharing of charge between two bodies. Now for that we need to have analyze on these points. On this point, these are step 1. We will first take two bodies and we will connect them. Then second step, the charge will flow from one body to another body till both acquire the same potential. And when they acquire the same potential, we have to calculate what is the common potential. Then we will calculate what amount of charge that flow from one body to another body, and then we will calculate the common potential, then what happened to the energy, and if there is a change in energy, either energy decreases or increases, then how much energy increased or decreased. Really there will be loss of energy, that part we will calculate. If there is loss of energy, how much energy has been lost because of this process. Now to explain this concept, we have two different situations. Either we will take two conducting spheres for this purpose, or we can take two parallel plate capacitor for understanding this concept. But for simplicity, I am taking two conducting spheres because two parallel plate capacitor concept is there in all the books, and generally it is taught in all the schools by all teachers. But this is a concept where we can understand and realize the concept very easily. Now suppose we will take two spheres. One sphere is A, another sphere is B, and A is having radius R1, B is having radius R2, and I have given Q amount of charge to sphere A, but no charge is present on sphere B. Now at this situation, we can see the charge on A and charge on B. Charge on A is Q, whereas charge on B is 0, but potential on the surface of the sphere A is 1 by 4 pi epsilon 0 Q by R1, whereas potential of B is 0 because charge is not there. Exactly in the similar way, we can calculate energy associated with the charges present on the surface of A is half QV. That half QV I can write half V is 1 by 4 pi epsilon 0 Q by R1, and as the charge is present, that's why Q will be multiplied. That is why half 1 by 4 pi epsilon 0 Q square by R1. It is the energy of A, where here energy means we are discussing only electrostatic energy. That way I am not writing electrostatic energy because we are calculating only electrostatic things. We are not dealing with any other energy. Similarly, energy of body B is 0 because charge on the body B is 0. Now when we will connect these two bodies by in terms of our through by wire, the charge will start flowing from the body A to body B. Why? Because body A is at higher potential, body B is at lower potential. Or I can tell body A has a huge amount of charge, it wants to share the charge with a hunger body, that is body B, which is interested to take the charge. Hence the charge will flow from A to B till both acquire the same potential. That means A cannot give all the charge to B. But there is another concept when both are concentric spheres, or one sphere is inside another sphere. At that time situation is different, but here the spheres are separated by some distance apart. That is why charge will flow from body A to body B. Now when Q amount of charge flows from body A to body B, after flowing of charge Q, we will analyze, or at that instant, at that time, the charge, energy and potential we will check. The charge on body A is Q minus Q because Q amount of charge has been given to body B. That's why charge on B is Q. The potential of A is, we know the potential of a sphere is 1 by 4 pi epsilon 0 charge on the sphere divided by its radius. That's 1 by 4 pi epsilon 0 Q minus capital small q divided by R1. Similarly, the potential of B is 1 by 4 pi epsilon 0 small q by R2. Similarly, energy of sphere A is half QV, that's why half 1 by 4 pi epsilon 0 Q minus Q into charge is also Q minus Q, that's why Q minus Q whole square by R1. Similarly, the potential energy or electrostatic potential energy of body B, as required charge Q is potential into charge into half. There is a half term you might be knowing from the earlier time. There is a half 1 by 4 pi epsilon 0 Q square by R2. Now this is the energy of A and B after just transfer of charge Q. But this transfer will take place till both acquire the same potential. Hence, at equilibrium, when there is no flow of charge from body A to body B, at that time, what will happen? The potential of A and B will be equal. And suppose we think that after transfer of Q, both will acquire the same potential. Then by taking those expressions, I will calculate. Now, if VA equal to VB, we can write VA equal to 1 by 4 pi epsilon 0 Q minus Q by R1, and this is also 1 by 4 pi epsilon 0 Q by R2. 1 by 4 pi epsilon cancel. That is Q minus Q by Q equal to R1 by R2. Now from this, if I will calculate in this process, I will calculate the amount Q that has been transferred from A to B till both acquired same charge is this one. Q equal to R2 by R1 plus R2 into capital Q. Now when this amount of charge has been transferred to body B, there will be certain change in potential energy, there will be same potential, and energy will be also there. Now when the B will acquire potential, exactly same amount of potential will be acquired by body A. Hence, let us calculate what is potential of both the bodies, or what is a common potential. Now common potential, now both are having the same potential, that is common potential VC. Hence VC equal to 1 by 4 pi epsilon 0 Q by R2. Either I will use the value of small q in the expression for potential of A, but using the same value in potential B will be very easier for calculating the common potential. Hence, by using this value of Q, I got the value common potential is 1 by 4 pi epsilon 0 Q by R1 plus R2, because 1 by 4 pi epsilon 1 by R2, and Q amount of the expression of Q I have used here. R2 got cancelled. R2 got cancelled. You see, these two got cancelled. When R2 got cancelled, hence VC equal to 1 by 4 pi epsilon 0 Q by R1 plus R2. Hence, I got the common potential. Now, this is the common potential. That means, at this situation, the body A will have this potential, body B will also have the same potential. Then, let us check what happens to the energy. Now, if you go for energy, that is electrostatic energy, before connection, energy of A is 1 by 8 pi epsilon 0 Q square by R1. We have got that one beforehand. We have discussed 1 by 8 pi epsilon 0 Q square by R1. It is the energy of A, but the energy of B was 0 because charge was 0. Hence, total energy before connection is this one. Initial energy is 1 by 8 pi epsilon 0 Q square by R1. Now, this is the energy before connection. But after connection, when both acquire the same potential or common potential, now energy of A is UA dash, I have written, that is 1 by 8 pi epsilon 0 Q into Q minus Q by R1 plus R2. We have already checked that one. Hence energy of B also we have calculated 1 by 8 pi epsilon 0 Q by R1 plus R2. Hence total final energy after connection will be 1 by 8 pi epsilon 0 Q square by R1 plus R2. Now this is the final energy. This is the initial energy. When we are thinking of this initial energy and final energy, now you see, numerator part is same, Q square. q square. Here 1 by 8 epsilon 0, 1 by 8 pi epsilon 0. But here numerator is r1, denominator is r1, whereas here denominator is r1 plus r2. That means denominator increased. As denominator increase, the value of the quantity decrease. Hence ui is greater than uf. That means initial energy was is greater than the final energy. From this expression we have understood, that is why we can tell there is always loss of energy. Okay, hence energy loss take place. If energy loss take place, then how much energy lost? That also we have to calculate. The energy loss is equal to, I can find out final energy minus initial energy, but already I have convinced myself, or we have convinced that delta U, or the initial energy, is greater than final energy. That's why I am calculating ui minus uf. Now if I will put the value of ui, that is 1 by 8 pi epsilon 0 q by r1, minus final energy is 1 by 8 pi epsilon 0 q square by r1 plus r2, and let me take q square and 8 pi epsilon 0 common. That's why q square by 8 pi epsilon 0 into 1 by r1 minus 1 by r1 plus r2. Now taking LCM, I can go through this. Now after taking LCM, r1 cancel. Now this is 1 by 8 pi epsilon 0 q square by r1 into r1 plus r2. Here r2 will be there. Now if R2 will be there, then delta U equal to R2 divided by R1 plus R2 into 1 by 8 pi epsilon 0 q square by R1, or I can write delta U equal to R1 by R1 plus R2 into UI. That means delta U, change in energy, is R1 by R1 plus R2 times UI. Now see, numerator is R1, and denominator is R1 plus R2. Denominator is more than numerator. That's why delta U, or delta U, is less than UI. Like this, we can determine the common potential, energy loss, when two charged capacitors are connected. Two charged capacitors are connected each other, which is there in your book. I will explain those things in the next video. Now here the question arises when delta U is positive, that means energy lost